Button accepted.
Hello, everyone, Devoxians. I'm quite surprised to see so many faces here because there's been a lot of productivity talks on this conference this year. So I'm glad that you joined yet another one, and I hope you're gonna learn a thing or two, or maybe three. My name is Bartosz Majsak, and it's quite a special place for me because I grew up literally across the street. So hi, mom, and hi, dad, especially dad because it's your day. And my last public experience or appearance was back in 2019, so long time ago, at the same conference. So bear with me because I might be a bit rusty. I haven't done much talks in between. Right, so I do work for Red Hat, and I must admit I betrayed Java like 5 years ago. So don't expect any super fancy tricks in your favorite language or your favorite ecosystem. I'm doing cloud dev tooling, so it's mainly Go. And I'm primarily involved right now in tools for developers which are leveraging Kubernetes and Istio. So you're going to see a few things based on this. My talk is Productive Developer of the Cloud Era. I won't give you a silver bullet nor opinionated chain tool on this talk. What I will try to show you instead is what kind of optimizations you can seek in your workflow and what kind of tools can help you achieve better productivity. So, 2 hours, 53 minutes. That's not my marathon personal best yet. Actually, I haven't run marathon. I was training for half, but I was sick. 2 hours and 53 minutes is the result of the study, which was performed among 2,000 office workers in UK. And the goal was to figure out what are the online habits and productivity of those people. And 2 hours, 53 minutes stands for the average amount of time per day where people are productive. Not a lot, huh? So let's dive into what they spend their time on in the meantime. So they spend more than an hour reading the news. And they spend 40 minutes discussing not so much work-related topics. They go for a smoke, if they smoke, for 23 minutes. They have to eat, so obviously they spend half an hour eating. Then they are relaxed, so they are making calls or text their friends or relatives. But they also are searching for new jobs at work. Right. So we have 8 hours of working day, and this is kind of a relic from the Industrial Revolution. And personally, I feel you shouldn't feel guilty if you are not hyper-productive during this whole time. But the question is, how long we can actually work in a so-called deep state? There is a term which is called deep work, and essentially it means that it's a work which involves a single cognitively demanding task on which you work without breaking focus for a prolonged period of time. And it was actually studied. There was a Swedish psychologist who spent quite a bit of time trying to answer the question, what is the most amount of hours per day we can actually be in this state? His name was Anders Ericsson, if I remember correctly. And it turned out it's 4 hours. And if you go to Stack Overflow or maybe Hacker News, and you will be lucky enough to find honest answers, you will see that some programmers are saying, yeah, it's between 4 and 6, something like that. Another interesting result of a related study is how people who are trying to keep focused for a longer period of time are actually scheduling their day. So one study revealed that people who are the most productive, they spend roughly 50 minutes of focused work, and then they spend 17 minutes on the break. So if you know Pomodoro, it's kind of like that, but it's a little bit extended. And the other studies are suggesting that the good way of putting yourself into the deep work is to slice your day to like 2 or 3 blocks of 90 minutes. And in between, obviously, don't procrastinate, but fill it with some shallow work. Let it be emails or some admin tasks, or maybe meetings, I don't know. So the next time, when you're going to feel guilty that you were not working for 8 hours, I mean, don't be, because science has your back. It's proven that we are not machines, we are just humans. So productivity, what does it mean? In the simple terms, it's a measure of how efficiently a person can complete the task. But how does it translate to our work, developers? Is it coding faster? I don't think so. I personally think that it's ability to remove the clutter, to be able to remain focused, and so to be in this deep work state. But how can it be done? Obviously, we can automate some things which are boring, or we can speed up those which are taking too long. Because if things are taking too long, then obviously you're gonna get distracted. So then when you're gonna try to go back to your deep focus, it will take you a while. So you won't be in the deep state continuously. So let's have a look how we can break those activities down. So how we developers work, and what we can improve. So we can think of it, and it's not my term. It was coined, I guess, by someone from Microsoft a while back. But it's quite obvious that we all do because we are agile. Because we work in cycles, right? It's a loop of sequence of tasks. The first one is, how do we code? I mean, how can we translate our marvelous ideas into programming language, but in a way that we don't spend too much time on something which can make us distracted? For example, if we mess around with the mouse and we try to find how to run such a stuff, this is obviously a distraction, right? So it's good to learn some key bindings. But there's also another aspect. How quickly we can start coding. How quickly, for example, we can onboard a new team member so that he will feel productive immediately. So back in the days, because I'm not that young anymore, I remember working in some industries like banks and whatnot, and that was taking me a few days. I was working as a consultant, and it was like a few days just to get my laptop set up with admin rights and so that I can install my tooling finally. These times are likely gone. We can use VMs to spawn our environments, or better yet, we can try cloud IDs. Anyone tried cloud IDs around? Okay, 2 people. I will show you a few. Right. So, this is typically how we start, right? We select the project, we check out dependencies, check out the branch, we view the README, so we learn how do we install this stuff, run the build, run the tests. So we have rough idea and some mind map, so we can start coding. But how about we just do this? We select the project and we are ready to code right away. And there is a few tools which you can use. One, which is quite popular, is GitHub Codespaces. It's an open beta, and they announced it more than a year ago. And back then, I was on the waiting list for 2 months. But now I tried when I was preparing some other demo on the talk tomorrow, which is 15 minutes, and I'll show you yet another productivity tricks for GitHub. It takes a day. So you get the VS Code in a runtime container, so you can essentially run all the things you need. You have a terminal, you have IDE, which is a VS Code with plugins for the language which the project is using. Or similarly, you can use Gitpod. It's a very similar service. Or if you are running Kubernetes or OpenShift, you can run Eclipse-Che. Eclipse-Che used to be called CodeEnvy, and it was like one of the first full-blown IDEs in the browser run in the cloud. So it's a fully functional build with a Kubernetes in mind, so one can say it's a Kubernetes native. And these 3 IDEs I showed you, they have 2 things in common. One is they are all based on VS Code. And the second one is, if somebody knows, I have a red fedora to give away, but just one. If you code in Java and you use VS Code, you are actually using Eclipse. Because underneath, VS Code uses what's called Java language server, and the Java language server is a Eclipse, good old Eclipse Java development tooling, but the backend, not the IDE. Okay, so Fedora stays with me. So that's the coding part, the exciting part. Then when we translate our thoughts into language of choice and it looks good, we obviously want to build. And it was easy. It was just compile and put the artifact somewhere on the app server. And in the cloud reality, not anymore. Because we have to pack it in the container. So we have to build the container image. And then we have to push it to the repository. And presumably update some manifest so we can deploy it to the cluster. So how can we speed it up? Brute force, meaning scale vertically, add more hardware. So you can have a beefy laptop. But the reality is that even a beefy laptop at some point will give up, because if your network or graph or services will grow, you won't have enough resources, right? I mean, literally, no one runs Netflix or Lyft on their machines. It's impossible. So there is another way. It's simple as that. We work smarter, but not harder, right? So we can find some tools, which I will show you, which cut the feedback loop. So we spend less time on compiling, so we slack less. We spend less time on the whole build chain, so we can quickly verify if our code works and continue be in the zone of the deep work. So the first thing which comes to mind is, let's speed up the container builds, right? So there are a few alternatives to Docker. The first one you can think of is the Builda. Builda is a builder which is kind of a drop-in replacement for Docker. It's underneath of Podman, which is alternative, a rootless alternative for Docker. It's a bit smarter / faster, because when you build your images, you can mount, for example, the system package manager cache, so it won't download it over and over again. But that's like a bare bone optimization, right? If we work with Java, we can, for example, use Eclipse JCube, which comes in the flavors of Maven and Gradle plugin, and can work without the Docker daemon, because it supports also, for example, Jeep. And on top of this, it can generate Kubernetes manifest. So if you start, you just want to experiment, or you are starting with the new service, this will generate some scaffolding. You can just throw it on in the Kubernetes, and it will work. You can use Co. Co is similar thing conceptually. It's essentially optimized builder for Go language. Not sure anyone writes in Go. Okay, so one person. Hooray. So it works is seemingly the same. It has a base image which is very slim, and then the next layer is what's the output of Go build. Plus, it can generate some manifest and update them based on some simple templating language. And the last one I would like to mention is actually a plugin for kubectl, so kubectl, kubecontrol, which is built, and it's a build kit CLI. So the whole idea here is that we throw away the loop of sending the image from our host to some repository, and then it's pulled into Kubernetes. It's essentially deploying the Docker build server to the cluster. If it's not deployed, sends your Docker file and your artifacts, builds it, push it to the local repository. So it's a bit faster. So the loop of building images is way more performant than what you would have with the old school / Docker traditional builder approach. But that's already an improvement. I believe we can do faster, we can go faster, and we can actually skip the whole build cycle, at least the build of Docker image. And there are few ways of doing it. One is to approach it in a way that you run some tool which watches the changes of your code, and you have a dev container in the cluster, and this dev container is fed with all the changes you make as soon as they are saved, right? So there's a special dev container building it continuously. There are few tools available. Obviously, all of them, unless I say explicitly, are open source. Codespaces is not open source. So one of them is Scaffold. It has the dev mode, and it allows you quickly to reload what you have written, and you have a faster feedback loop of code build execution. Then a bit more sophisticated, still very similar, is Tilt. Difference is on the basic level is that Scaffold has a YAML config and Tilt has a config in Python, but YAML is assembly of the cloud, so you should stick with YAML. But Tilt has also a Kubernetes UI, so you can see all the logs, all the pods, and everything. It's a bit more feature-rich. And there is also OpenShift Do, which is yet another tool allowing you to do this smart syncing of the dev container. So I guess to understand it better, it's good to see what's happening quickly. It's worth more than 1,000 words. Okay, so I have a simple project which has the Docker file, pod, Kubernetes pod, main go, and the Scaffold config. So my Kubernetes pod is just simple, right? It just points to the image. Then another file worth mentioning is the Scaffold config. So there you only say what kind of artifacts you want to push and what you want to deploy. And then we have our super sophisticated program to work with. So it's a hello world, and we're gonna try to modify it. So how do we do that? We start Scaffold dev, so it listens to our changes, but it will also build the container first and push it to our local cluster. So that's a bit faster for a few reasons, but that's my local cluster. You see that the image is already there. And then I will open up my favorite IDE of choice, which is VI. You can see that already the service is running and it's saying hello world. So I do the VI Vim. I will change hello world to surprise, surprise, hello Devoxx Poland. If I can type correctly, I will write, and then it picks up the changes, reloads, and immediately you will see it says hello Devoxx Poland. But the thing is, this is the same pod with the same container, so it's way faster than traditional rebuilding and pushing it back and forth. Right. So there's another approach, obviously, and this approach relies on smart routing. And there's a new term which is called remocal. So you run your stuff locally, but it pretends that you're in the cluster. The way how it works in a nutshell is that when you go to your service as a regular user, you will hit the traditional deployment. But as soon as you want to run work on the changes of the service, the tool will do the following. It will deploy the special pods with some SSH tunnels. You run the process locally, and based on some criteria, let it be host or the URL query param or some header, it will be rerouted to your machine. So, and it obviously be directional. So it feels like this stuff runs in the cluster because it is able to talk with other services. I mean, this is very simple, so there are no other services involved. But it allows you to test your changes only for this specific traffic, right? So you can have, let's say, even a special dev user which can test stuff on prod if you wish. So there are a couple of tools in this space. The beauty of this solution is that you only run what you need on your laptop, plus you use whatever tools you like and you feel productive with on your laptop. The rest stays in the cluster. So you don't have to run Kind, you don't have to run Minikube, you don't have to run whatever other solution you can think of, you just run what you need. So the first I'm aware of, which showed up a few years ago, and it's part of the CNCF, it's telepresence. Then there is an offering from Microsoft, which is called Bridge to Kubernetes. Here, the open source part, from what I recall, is only the VS Code extension. The code, which is the backend controller, is not open source as far as I know. Then there is Octeto, which is open source and has some software as a service offering. They all work in a similar fashion. The Garden, and there's the workspace, which I'm involved in. And if you think about that, and you, for example, run your local process with Quarkus dev mode or Spring Boot dev mode, it gives you kind of a similar experience like with JRebel. Anyone use JRebel? Raise your hand. Jesus, I'm old. Or you are lucky that you don't deal with this. Sorry, JRebel creators. Forgive me. It's recorded. Right, so we mess around, we build, we run our stuff, it doesn't work, obviously, so we have to debug. With tools like Scaffold, you can think about port forwarding. But actually, with this remote local approach, you simply just attach your debugger to whatever runs on your machine, so it's a fairly simple thing. We presumably want to test as well, so normally if you work on the feature locally, probably just run some fast tests, so unit tests and maybe some integration tests, and the rest you delegate to the CI, defer, right? It's not important now. Here we can also optimize. There is an IDE extension called Infinitest, but it's not actively developed from what I've seen, but worth checking. It's a great idea. There was JUnit Max, which is kind of the source of inspiration for Infinitest. But then there is a Launchable. It's a product, so software as a service, cloud offering from creator of Jenkins, Kosuke Kawaguchi. And it's free for small companies, so less than 50 people and open source projects. And it essentially does some smart test selection prediction. So you can, for example, run tests which are affecting the code changes you pushed first, right? It can run tests which are known to be most flaky first, and so on and so forth. I mean, you can do it on your own as well by introducing some categories, but this is smarter. It has some machine learning involved. And this loop, to surprise of everyone, it's called inner loop, right? It's our own work, the cycle of activities we do as a developer, or if we pair then with some wingman, while we are working on the task. So if we fixed everything, the tests are green, at least the fast ones, we decide we are done, so we're gonna raise the pull request. And then another loop starts, right? There is a code review. And then obviously human beings are involved. So I don't know how to optimize them except of maybe have some influence on the process of culture so it's not hanging in limbo infinitely. And then there is a CI/CD which kicks in. So we run the build, we run the compliance tools which can be linters, so check style, huddle for Docker, code analyzers. We do the vulnerability scanners, right? So we can run SNIG, which is a general purpose dependency scanner, or we can run, so for every language, or most of the languages. Or you can run Claire, which is container specific, and then it checks your OS packages if they are some CVs known to the world, right? Which is this one, right? And then we run some tests, probably broader tests, some end-to-end tests, maybe some more sophisticated integration tests. And of course, this is not really sequential. This can be parallelized as well. So it just fits to the loop narrative, so I put it in the loop. And then the last part of the step is maybe we would like to see those changes live, right, before they hit the production. So there is deploy step. And this is hard, right, because provisioning environment just for the sole purpose of checking your changes, it's expensive. And it's not really straightforward if you want to have it similar to production. And if we have a shared environment and we have multiple PRs which are affecting the similar things, that might be also tricky. It's quite a bit of cost involved to maintain such an infrastructure. But we can leverage the tools which do smart routing for exactly that. And surprisingly, that's called outer loop. So this is where we collaborate. Right, so it's time to see it in action. This is going to be a simple web store which has two backend services and the web frontend. Runs on OpenShift. So OpenShift is you can think of it like a Red Hat Kubernetes distribution with some enterprise-grade features. It will have Tecton, which is a Kubernetes native CI pipeline orchestration engine, and there will be Istio service mesh, so we can do some routing. And we leverage remocal approach, so the smart routing, as well as the preview on the PR on GitHub to see a bit of the outer loop. And with all these services mentioned, many things can go wrong on the live demo. So, as a professional cooking chef in my show, I prepared everything earlier. So, it will be shown on the screen. I will walk you through, but you are open to ask questions. So, let's say it's a bit of a win-win. I'm not sweating, stressing out that stuff will fail. GitHub is known to fail lately, unfortunately. And you can ask questions whenever you like, or we can leave it at the end. All right, so we start. We go to the issue. We have a bug which says there is a missing information about the inventory in our cool store, right? So we see there is nothing there. And we can see it on the website, because we validate it on the website too. Then we go to Kali, which is a part of OpenShift Service Mesh, or actually it's part of Istio. It's a dashboard which visualizes how Istio is configured, shows you what are the services, destination rules, visual services, and how the packages are flowing, what are the error rates or whatnot. This is simple demo, everything is green. There are only 4 nodes, so not a lot of shiny things to show, but if you use Istio, definitely check it out, because it can give you a lot of good insights. So yeah, we know that the inventory is not showing up, and we know that most likely the inventory service is involved. So how do we start digging? I mean, do we crawl the logs of the container, we tail, we do some grabs or something like that? It's not really productive, is it? We can use some stack for analyzing logging. So for example, on OpenShift, you can use the stack of 3 pieces. There's a fluentd, which collects and normalizes the log output. There is Elasticsearch, which you can think of as a warehouse. Everybody uses Elasticsearch, or anyone using Elasticsearch? Few people, cool. And then there's Kibana, which is a nice visualizer and let you query stuff, right? Okay, so what do? We're gonna go and search for the message, which is easy. It has an inventory and an error. And we can see that we have a warning that the item number 44436 has a weird status. So we have to go deeper. So another tool we can use is something for distributed tracing. OpenShift comes with a Jaeger, which is inspired by Dapper and Zipkin, I guess. Gives you a distributed tracing, the context propagation, I guess also transaction monitoring and some root cause analysis. This demo is simple, so we will just look at the traces. So we're gonna search, and we see there are few traces available. So we say, okay, show me 444436. And now I can have this one highlighted, I can dig into it. I have tags, so I can see what kind of metrics I can gather, but I see smelly stuff, that the request size and the response size are 0, so something ain't good. Right, so we know what's wrong. We have our project checked out, because I did it earlier, so we can start coding, right? We have just 2 pods. There is an inventory v1, that's our service, and this is what we gonna connect to and cheat that we are connected to the cluster. So I go to the VS Code. I have this very simple Quarkus service, which is a REST endpoint, and just queries the database trying to find the corresponding entity based on the param item ID. So I can say run task, which is root to inventory. This underneath will start Istio workspace, and we can see on the OpenShift console that we finally, all of a sudden, have a new pod. Oh, the laser is not working. And this is my special pod, which is on the cluster, but will route my service back to my local process. So with that, I guess we can set the breakpoint. So I go there again. I set the breakpoint. I will make it conditional because I know where I want to stop. So I want the ID of 44436 equal to whatever comes to my REST endpoint, right? So I have a breakpoint run. I go to the website. I will refresh one. This is a special one. And you see, I hit the breakpoint, and there is no inventory available, no entity matching this ID. So quick and dirty fix, I will just say, if it's null, create, and it's good enough, at least for my rusty Java skills. So I create a new instance. I will obviously use setters, because Java beans, hooray. And yeah, we probably will have a fix working in our cool website. All right, so I refresh, and obviously that's the demo, so not all the things are working flawlessly, as you will see, because I have to refresh again. And now, boom, I hit the breakpoint again. But I know I'm good, so I refresh, I go back to the browser, and it's actually marked not in stock, right? Then I go to the prod. I will explain in a minute what's the difference. I will refresh, and the item is not there. So the red one is prod, that's a regular URL, and here I'm just passing this special route, which I configured in my task. And this is propagated through the whole flow of requests. And this way, Istio knows to which service you should direct, right? So I have two alternative routes, and I can verify without messing up with the production users. Okay, so now I'm good with this, so I'm gonna kill. I stop my work, so the pod is not there anymore. It's gone. If we look at Kiali, you will see it's a snapshot from last 5 minutes. So there is my service still there, and you can see that the requests were flowing through it, and they were both talking to the actual database. And now I'm good with the changes, so I will go ahead and raise the PR. I will say it fixes everything. And I will push it and publish the branch so that I can go to GitHub and open the pull request. I could do it from VS Code, but I forgot to install the extension. So there is an extension for that. So I create the pull request, and there will be some checks showing up. There is no required check, but one is kicking in, and that's the Tecton build, right? You can see that there is something going on. So we can see how the cluster reacted on the webhook coming from the GitHub PR. I have a few steps in this build and preview. It will just clone the repo, obviously, build my service, because my job will only react on the services changed. Another optimization. If you have a mono repo, then the image is created, the preview inventory, the service will be created, the session URL, which is the preview URL, and then we go with the communication, the feedback to my pull request. So that was the pipeline definition. This is the actual pipeline run, so you can see it runs. But as it is recorded, and it's actually not that fast, we can travel in time and just see that it was successfully finished. So now, let's go back, and actually, I can check if my fix was there, right? And the prod is still not affected, which is great. The difference is that now this pod is not the pass-through to my local process, right? Because if I would do it this way, and shut down my machine, this is gone. No one else of you can see if it works or join this work, right? So there's no magical tunneling. It's just the image which has this new deployment, which is the same as the original one, except of the code changes, right? So I'm brave enough. I can merge my pull request, and now the new jobs will start. which is one which is undeployed the preview, and the one which will deploy the actual application. So we can see it's fairly simple stuff. It's updating the job, the image, and it's pushing to the production. And after a while, the production will have the fix, and there is no deployment of the preview anymore. So that was the tour of the inner and outer loop with one important set of tools, which is the smart routing, so the gateway drag to testing on prod. Right? All right, so what are the takeaways? I mean, the main one, which was for me hard to believe back in the days, you can't be productive the whole day. It's a myth. If any coach will tell you that any YouTube ad or Instagrammer, don't believe it's a lie unless they have some special product to sell you. So don't feel bad if you didn't code the whole day like crazy, and remember that there is a scientific evidence that you shouldn't. Right, then, with these tools I mentioned, you can see that there is quite a lot of innovation and a lot of work happening to actually shorten the feedback loop. Obviously, you can start with your tools you are using, for example, how to introduce parallelization in your builds, right? If you use Gradle or Maven. Gradle, I guess, has also this test selection feature. I think they lately announced this. So that's actually cool stuff to do. I remember from my past project, we had this golden rule, or the important rule, that if build exceeds 8 minutes, there is someone in the sprint assigned to it to fix it to go below, right? So we were looking at this, shortening the feedback loop. I mean the full build on the CI server, not the local one. But if you will go away from this talk with only one thing in mind, is that if you're gonna develop microservices architecture on the cloud, forget about running it locally. Because you will reach the limit where, like my old laptop, which is 6 years old, when you compile, it's gonna go up to 90 Celsius, so we can fry some eggs on it. Right, so check out telepresence, bridge to Kubernetes, all the remocal stuff, Istio workspace, because there's lots of cool innovation going on. And I think that's a very appealing approach to enable developers being productive while using the Kubernetes magic. So that's all I have. Thank you very much. I hope it was interesting. If you have some questions, I'm happy to answer them now, or you can find me at the Red Hat booth till the party, I guess. So, thanks. And I have a Fedora to give away. So, what was the name of the tool which lets you redirect the traffic to your local process, and it's in CNCF, is a CNCF project? The most popular one, come on. Starts with T. I guess you were first, okay? Okay, I need to work on my talk in the way of how to set the message better, or articulation. All right, thanks a lot and have a great rest of the Devoxx. Tomorrow I have a quick talk about GitHub, and I will show you a few cool things so that you can be more productive in GitHub. So you can join me.